Hello everyone. This is my project demo, and the name of my project is a performance improvement of IEEE 802.11 in ad hoc architecture based on wireless network. So I'll begin my demo. First, I want to introduce the problem under study. With the rapid development of wireless network as an important connecting mode, ad hoc net architecture has been more and more popular. And as we know, for a better performance in communication, one important point that decides the efficiency of ad hoc network is the route selection. But packet transmission in ad hoc network is with many different nodes, and the different paths has different path loss and time delay. The transmission between different nodes is also affected by noise and interference, which will influence the quality of signals and the success rate of transmission. To solve this problem, the goal of my project is to better use ad hoc network. I focus on looking for the best route algorithm between two nodes, which has the least propagation loss. I will use the number of the hops as a standard of propagation loss because fewer hops means less transmission distance. In the second part, I would like to introduce the existing approaches to solve this problem. And in this project, the problem is the algorithm for the routing table. Nowadays, there are two main kinds of algorithm. The first one is called the Bellman-Ford algorithm. The main advantage of Bellman-Ford algorithm is it is easy to understand and implement. The principle of Bellman-Ford algorithm is, if a node is in the shortest path between node A and node B, then the path from the node to node A must be the shortest path. Similarly, the path between the node to node B also must be the shortest path. And the second main algorithm is called the Castro algorithm. The Castro algorithm is an alternative algorithm of the Bellman-Ford algorithm for the shortest path selections. But it's to look for the shortest path from one fixed node to other nodes. This is different from the Bellman-Ford algorithm. It is more efficient than Bellman-Ford algorithm, but it requires that the cost of every path is positive. The main idea of the Dijkstra algorithm is keeping increasing the closest node from shortest node. So the Dijkstra algorithm is a kind of iteration algorithm. Now I would like to introduce our new approach. And because in ad hoc network, the cost of every path is always positive, so we choose to optimize the Dijkstra algorithm to decrease the propagation loss due to the high complexity of the basic algorithm. Compared to the Bellman-Ford algorithm, the basic Dijkstra algorithm is more efficient, as we discussed before. So that's why we choose to optimize the Dijkstra algorithm and not to optimize the Bellman-Ford algorithm. And now there are some main steps. The first one is to devise the algorithm. The key of the new algorithm is we don't need to calculate the shortest path tree for every node in the network if this node has only one interface through which another router can be reached. Instead, short-circuit this computation and just install a default route in the traversal method. This is very important because, as we know, in the basic and Dijkstra algorithm. We need to calculate the distance of every node at every iteration. So with this new algorithm, much calculation time can be saved. And step 2 is construct the virtual ad hoc network. In this project, we choose NS3 as a simulation tool. NS3 simulator is used in the simulation of routing protocols and is very popular in ad hoc networking research. Step 3 is the algorithm test. And the first is test the algorithm in a basic CSMA network. And the second is test the algorithm possibility of recovery. And the third will put this algorithm in a real ad hoc network. So in the first test, I construct a CSMA network of 4 nodes, and every node has only one path to each other, and I will use this optimized algorithm to help the router to find the shortest way. And the second, I still use the technology as step 1, but I'll cut one pass at the 5 seconds, and then I'll test the recovery abilities of the routers. And 3, I'll add some other point-to-point nodes to the CSMA network, and then I'll put some of the nodes into a Wi-Fi network, and then I will implement the ad hoc protocols on these nodes. So this can be a very true and virtual ad hoc network. Now I would like to show you the demo of my project, and because NS3 had been run under the Linux environment, and this software can't be installed on the Linux, so I can only use some capture screen to show the result of the program. So as we see, this picture is the result of the test 1, and from this picture we can see, and if the IP address of the node 1 is 10.1.1.1, and I send 1024 bytes to the node 3, and then we can see the node 3 successfully received the bytes, and then he replied to the node 1 that it has successfully received the bytes. And this picture shows the process of the test 2, and as we say, in the first 5 seconds, that the all passes are available, and we can see the nodes. We can see that when node 1 wants to send the packet to node C, it can directly send to node C. But after 5 seconds later, it have to send the packet through another way. So as we can see, the IP address changes because it shows the IP address of the middle router during its pass. And this picture shows the result of the test 3. In a very true and virtual ad hoc network, we successfully send the packet from node 1, and the node 3 successfully receives the packet, which proves the accuracy of our algorithm. So this is the end of the project demo. After hard work on this project, and also under the help of professors and the teaching assistant. Finally, a satisfying result is achieved, which proves that the new optimized Dijkstra algorithm can improve the performance of the communications. And through this project, I think I have learned much of things. First, I understand more about the levels of the network. I know more about how the protocols implement on the different levels of network. And the second, I enhance my ability of program because NS3 has a very high requirement on the C programmabilities, and I have to self-learn a lot about the C program and to reach the goal. So that's all. Thank you very much.